All right, I want to welcome all of you back to Honors Algebra 2. Chapter 9 is broken up into three sections. We just took the test on section 9.1, and so this one's going to be 9.2 and 9.3. So the first topic we're going to talk about is drawing angles in standard position. So we're going to give you an angle measure and ask you to draw it. Now, looking at the picture over here at the right-hand side, you'll notice that the initial side is always the positive side on the x-axis. So every single angle that you draw will start at that position. So that is the initial side. And then depending on how many degrees that you actually go, this is referred to as the terminal side, basically where you're stopping at. So again, drawing an angle measure. An angle measure is in standard position when its vertex is at the origin and the initial side lies on the positive side of the x-axis. So again, always start on the positive side of the x-axis, and then you'll rotate going around counterclockwise. Now we're going to talk a little bit about that here in a quick second. If it's a positive angle measure, you would go counterclockwise. If it's a negative angle measure, you would go clockwise. You're going to go that direction. So again, positive angle measures going counterclockwise, negative angle measures going counterclockwise. So again, all the way around. Okay, so if you have something that's more than 360, you're just going to go all the way around the circle, and then you're going to continue to go. So again, the terminal side of the angle can rotate more than 360. That is possible. All right, so I'm going to draw an angle measure in standard positions. So I'm going to draw just a regular grid, XY grid, 240 degrees. So again, I'm going around positively. So there's 90, 180, and 240. Now, we're not going to get out a protractor or anything like that. Ultimately, I'm looking for is the angle drawn in the correct quadrant. So if it is drawn in the correct quadrant, then you'll be good in this particular situation, okay? Now, later we're going to talk about reference angles and things like that, but for right now, just drawing the angle in the correct quadrant. So 500, positive 500. So I'm going to go all the way around here because there's 90, 180, 270, 360, 450, and then we're talking about 50 degrees past that. So again, we're going to be in the second quadrant. Negative. So now going around the other direction, negative 50 degrees. So just drawing the angle in the correct quadrant for right now. Coterminal angles, okay? An example, 500 and then 140 are coterminal angles. I'm going to draw both of those just so you understand that. 500 we just did a few seconds ago, but 90, 180, 270, 360, 450, and then 50 degrees past that. But if I drew 140, there's 90 and 50 degrees past that. So notice that these two have the exact same picture. Are coterminal because the terminal side coincides, meaning the exact same picture. An angle coterminal with a given angle can be found by adding and subtracting 360. So anytime you add and subtract a 360 degrees, you are basically getting to the exact same spot. Think about this. If I was facing one direction and I jumped up, went 360 degrees, and landed, I'd be facing the exact same direction. So anytime we're talking about a coterminal angle, we're talking about the exact same angle, just merely 360 degrees difference. All right, and I realized that some of you didn't realize it, but I jumped up and did a 360. Some of you probably don't believe that. All right, here we go. Find one positive coterminal and one negative coterminal for each. So if I want to find a positive coterminal, I'm going to add 360 degrees. So if I added 360 degrees, I'd get positive, 285. And then if I subtracted 360 degrees, I would get negative 435. So those two angles would be coterminal to negative 75. So again, adding and subtracting 360. Now, the next one's a bit of a twist, and yes, this one's on your test later on. I add 360, then I would get 820 degrees. If I subtract 360, I'd get positive 100 degrees, but I need to subtract another 360 subtract another 360, and get negative 260. Remember, it's asking for one positive and one negative. So positive 820 would be a coterminal. Positive 100 would be a coterminal. And negative 260 would be a coterminal. And again, they just want one positive and one negative. So sometimes you might have to subtract more than once. Like you might have to subtract 360 and you might have to subtract 360 again. Or you might have to add 360 or add 360 again in order to get a one positive and one negative coterminal. Every time you add and subtract 360 degrees, it creates a coterminal angle. All right, now for the big topic of the day, and actually probably the big topic of the entire section. We're talking about radians. Angles can also be measured in what's known as radians. This is an entirely different measuring system. It'd be like saying the metric system compared to the English system. So instead of talking about feet and inches, you're going to talk about meters and kilometers. Okay, so this is an entirely different system. To define a radian, consider a circle with a radius r centered at the origin, as shown. 1 radian is the measure of an angle in its standard position whose terminal side intercepts the arc at r. This is actually considered 1 radian. If I went r on the circle and r for a radius, that is considered 1 radian, that angle measure. Do not worry about actually calculating what 1 radian actually is. Because the circumference of a circle is 2 pi r, there are 2 pi radians in a full circle. So the degree measure of a radian measure related to the equation 360 is 2 pi. Circle this if you have notes printed out on this. This is your conversion right here if you want to go from degrees to radians. 180 degrees equals pi radians. Now, what that means, in a circle, if you went half of the circle going around is pi, and the other half is pi. So a full circle is 2 pi. So a half a circle is pi. Now, here's the actual conversion. So if I actually wanted you to convert from degrees to radians, here's what I tell everybody. And I'm going to actually, you are always going to multiply by pi over 180 if you are going to radians. Notice that what you are converting into is on top. That's what I try to remember, okay? So if I'm converting to radians, then it's pi over 180. If I am converting from radians to degrees, this is if I wanted to go 2 degrees, then I'd multiply by 180 over pi. So we got a couple of examples coming up here, but if you want to go from degrees to radians, multiply by pi over 180. If you want to go from radians to degrees, multiply by 180 over pi. So here we go. I want to convert 150 degrees into radians. So I'm going to multiply by pi over 180. Remember, always remember that if you're going 2 radians, the pi goes on top. If you're going 2 degrees, the pi goes on the bottom. Now, multiply across. So I get negative 150 pi over 180, and reduce. So you're always going to reduce your fraction. So I know this reduces to negative 15 pi over 18 because they multiply, or they both divide by 10. And then they both divide by 3. So negative 150 degrees is the same as negative 5 pi over 6 in radians. Going the other direction, if I had 9 pi over 4 and I wanted to turn this into degrees, notice the 180 goes on top because I'm trying to go 2 degrees. And then what happens here is the pi and the pi will cancel. So then I get 9 times 180 is 1,620. Still divided by 4 is 405. So 405 degrees. So again, 9 pi over 4 is equivalent to 405 degrees. I'm going to be honest with you. We are not going to be doing this that much. It's good to know, it's good to understand, but when you are given something in radians, you are going to want to keep it in radians. You are not going to want to transform this every single time from radians to degrees or even from degrees to radians. Here's the big ones right here. These are what they call the special angles. This is ultimately what you will need to know every single time. Every time you're going pi over 2, this is 90 degrees. Every time you're doing a pi over 3, okay, pi over 3, this is a 60 degree. Every time you got a pi over 4, this is a 45 degree. And every time you got a pi over 6, you're talking about a 30 degree. Now, I might even add one more. Every time you have a pi, you're talking about 180 degrees. So I might add one more in. So this little picture over here, you will not have to memorize that picture, but ultimately watch what happens. And I'm going to use different colors here. Let's talk about the pi over 2. So here we are on our terminal side, or excuse me, our initial side. Pi over 2 is 90 degrees. So what's 2 over 2, and 3 over 2, and 4 over 2? So again, every time you go 90 degrees, you're adding another pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. 90 degrees each time. Now I'm going to do it with 60 degrees. I'm going to circle it as we go. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. Notice you're dividing up the circle into 60-degree increments. So every single time, here's 1, 2, 3, 4, 5, 6. You're dividing up the pi, or dividing up the circle, into 60-degree increments. So now let's do 45. So I'm going to erase this quick. So now every time you get a pi over 4, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So again, now you're dividing up the circle into 45-degree increments. Now for the hard one, or not the hard one, but now for the one that probably requires a little bit more understanding. 30-degree increments. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So now you're dividing this up into 30-degree increments going around the circle. I did add pi just because you can go in increments of 180 as well. So 1 pi, 2 pi. And that's important to understand that every time you go 1 pi, you're going 180 degrees. And we'll get into that in just a minute when we start actually drawing these angle measures. So just like you drew angle measures in degrees, you now can start drawing angle measures in radians. Here we go. I want to draw 4 pi over 3, just like I drew degrees just a little bit ago. So 4 pi over 3. So that is 1. We got all the way to 1 pi, and then 1/3 more. And I know that wasn't a very good explanation, so I'm going to talk about this one more time. Every third is 60 degrees. So we're talking about 4 60-degree angles. So 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi. Okay, now some of you might say, well, why can't I just convert it into degrees? I understand that, okay, and that feeling will be there a little bit, but you got to start understanding everything in radians. So now, when I'm talking about 4 pi over 3, I always like to think about it as a mixed number. It's 1 and then 1/3. So 1 pi goes from is straight across 180 degrees. Remember, that is 1 pi. So then 1/3 pi is only an additional 60 degrees. So hopefully that made a little bit of sense, and hopefully we'll continue to practice that. So here we go, -5/6 pi. Remember, negative angle measures go clockwise. So now we're talking about 5 30-degree angles. So again, 1/3, 2/3, 3/3, 4/3, 5/3. There's going to be 5/6. Sorry. 1/6, 2/6, 3/6, 4/6, 5/6. Notice it's just short of being 6/6. 6/6 is, and it's hard saying that, is there's 1 pi, or 6/6. So if I only want to go 5/6, I am short of going all the way 180 degrees. So that's we're drawing negative 5/6 pi. Positive and negative coterminals now. Again, coterminal angles are adding and subtracting 360. Well, what is a coterminal angle then in radians? Instead of adding and subtracting 360, you're going to add and subtract 2 pi. Earlier, we talked about the fact that 360 degrees is equivalent to 2 pi. So if I added 2 pi, so plus 2 pi. Now, a little fractional work here. Getting a common denominator, 2 and then 7/6, this would be 12/6. So a coterminal angle then would be 19 pi over 6 because I added 2 pi and got a common denominator. So I'm going to subtract 2 pi, which would be the same as subtracting 12/6. And so then if I subtracted 12/6, I get negative 5 pi over 6. Again, adding and subtracting 2 pi. Adding and subtracting 2 pi gives you a coterminal angle, just like adding and subtracting 360 got me a coterminal angle. So if I added 2 pi, which is adding 8/4 pi, then I would get 7 pi over 4. So that's adding 2 pi. Subtracting 2 pi, or subtracting 8 pi over 4, then I would get negative 9 pi over 4. Again, just like before when we added and subtracted 360, you might have to add and subtract 360 multiple times. You might have to add 2 pi multiple times in order to get one positive and one negative coterminal angle. Draw the angle in standard position. So we've done this already before, but this gets a little bit more complicated. We're just going to draw it, just like you would draw in degrees. So 17 pi over 3 is equivalent to 5 2/3 pi. I realize that usually we don't talk about mixed numbers, but with this, it's actually easier to understand if you have mixed numbers. 5 2/3 pi. So you ready? We're going to draw this. 1 pi, 2 pi, 3 pi, 4 pi, 5, and now all we need is 2/3. So 1/3, 2/3, it's in the 4th quadrant. Okay, because we're dividing up the pi into 1, 2. So we're dividing up that half of the pi into 2/3. So the next one, again, I think it's easier to understand this if we talk about it as a mixed number. So this is negative 2 3/4 pi. So here we go. Negative 1 pi, negative 2 pi, and now we need 3/4. So here's 1/4, 2/4, 3/4 pi. So understand drawing an angle measure in standard position. You have to be able to draw angles in radians. You can't be converting every single time from radians to degrees or from degrees to radians. The further you go, and yes, radians is actually the measure that is used the most in trig pre-calc and calculus. So most of the time that we talk about things in radians, it's more accurate than degrees. Last topic, and this is kind of just a throw-in topic a little bit, is a sector. Is the region of a circle that is bounded by 2 radii, so part of a circle. The central angle theta of the sector is the angle formed by the 2 radii. There are simple formulas for arc and sector as long as things are in radians. Okay, I want to stress that. It's got to be in radians for these formulas. The arc length. Okay, so if I want to know how far it is on the outside of the circle, the arc length is equivalent to the radius times the angle. And remember, in radians. The area of the sector. So I want to know what this area of the circle is. Okay, it's half radius squared times the angle. And again, in radians. So these are two formulas. Okay, so there'll be at least one question on your test that'll ask you for an area or will ask you for an arc length. Okay, so here's a baseball diamond. Softball field forms the sector of dimensions as shown. Find the length of the outfield fence. So I want to know how far is it from the left field flagpole to the right field flagpole. Well, the formula that we learned on the previous page, the sector formula, is I'll flip back if you need to, is radius times angle measure. Okay, so radius in this case is 200. Now, they gave it to me in degrees. The formula is in radians. So if I had to transfer 90 degrees into radians, you're talking about pi over 2. So now 200 times pi over 2. And so I'm going to find the distance from one flagpole to the next flagpole would be 200 pi over 2, which is 100 pi. Area is half. So that formula, remember going back to the formula, half radius squared times angle measure. So now 200 squared is 40,000. Half 40,000 times pi over 2. So we're talking about 20,000. Running out of space here. Give me a second. See if I can move this down a little bit. 20,000 times pi over 2, which is 10,000 pi. Now this is in feet, if I remember right. So yes, this should have been labeled 100 pi feet, and this would be feet squared then, because it's an area. Your first assignment is actually a dual assignment. You'll have a worksheet to work on, plus a few book problems. Be safe. Again, we're trying to do our best here as we can. If you have questions, make sure you're talking to myself and Ms. Kinsel. But again, good luck with everything, and I hope it goes well.